In this video, I'm going to show you some of the features in Excel that we're going to use for Section 5C, which is making a bunch of different types of graphs and displays. So the first thing that we're going to look at is this example where I surveyed a previous class of mine and found out how many pets they'd owned in their lifetime, and then counted how many owned each of the different number of classes. So I had 12 students that had had between 0 and 3 pets, I had 8 students that had 4 to 7 pets, and so on. And just listing out the different categories and the number of students that fell into each category is what's called a frequency distribution. So frequency distribution is just a chart that has different categories and then the number or the frequency of data that fell into each category. We can also make a relative frequency distribution, which instead of showing the number of points, we show the percentage of the points that fall into a category. So the first thing that we need to do to find a relative frequency distribution is to sum our frequencies to know how many data points we have. So in this case we had 31, and then we'll take each category's frequency and divide it by the total to get the percentage that fell into that category. And if your chart isn't showing up in percents, if you go up near the top where the little percent button is, you can click on it and you can add and subtract decimals to see however many decimals you want to look at. But what we see is that we had 12 students who had owned between 0 and 3 pets, and that represented 38.71% of the class. And one thing to note about this frequency distribution is that it's representing quantitative data. It's numerical data. I asked the students, how many pets have you owned? And they gave me a number. So that's classic quantitative data. Another thing that we can include, besides just the frequency and the relative frequency, which is the percentage, is the cumulative total. And that just tells you how many data points you have down to a certain part in our chart. So for our first line, we have 12 data points. When we go down a line, we get 8 more. So if I take the 8 more data points that I have and add it to the 12 that I already have, that gives us a cumulative total of 20 for my second row. And if I drag that down, we see that at the third row I'm up to 25 points, and I get 2 more to get 27, and then 4 more to get all 31 points. So these are the 3 different columns we can show, counting the points, showing the percentage of the points, and then coming up with that cumulative total. So a graph, or they say a picture's worth 1,000 words, a graph is even better. So if I want to turn this chart into a picture, specifically I want to show my frequencies in a bar graph. We call this a histogram. So what I could do is I could highlight my labels and my frequency columns and then go up to Insert and make a column chart. And I'm going to pick that very first column chart. And a histogram has the bars touching each other. So if I go to the Design menu under Chart Layouts and pick Layout 8, that's going to make all of my bars touch, so I can label it as number of pets, the frequency, and maybe I'll title this, let's see, pets owned by class. It doesn't really matter what you label it. And this is a histogram because our bars show us how many students fell into each category, and all the bars are touching, and it's a very easy graph. We can see most of the students have had 0 to 3 or 4 to 7, but then a couple have had a good number of pets. Maybe they've lived on a farm or had a bunch of goldfish or something like that. We can make a very similar chart with our relative frequencies if we highlight our classes and then hit Control and then highlight our relative frequencies. It's going to get those 2 columns highlighted, and then Insert Column, same 2D column, scooch it down here, again Chart Layouts, Layout 8. Now I can label it number of pets, percentages, and then pets owned by class. And if you notice, these 2 graphs are identical, and they should be. They're showing the exact same data. The only thing that's different is whether we're labeling that vertical axis with the frequency or if we're labeling it with the percents. And if I want to play around with my chart, I can do a lot of fun things. Excel lets you change colors and lets you change designs. I can also add in things like grid lines. Maybe, let's see, how do I want to do this? On the home menu, I can maybe add in some borders. Let's maybe add in borders, let's see, all around the outside. Maybe I want to put, let's see, maybe a border underneath the top row, so I can add a bottom border. If I want to separate the columns, I could add in some right borders. And you really can just play around with this, depending on what you think looks nice. There's a lot of other features. You can make things bold, you can change the colors, but I like to keep things kind of basic. But Excel's fun because you get to play around and make things look really pretty. So on the next tab down at the bottom, we have eye colors. And again, this was one of my previous classes, and I tallied how many of them had the different colors eyes. And this is a classic qualitative data because when I said, what color eyes do you have? They said, I have blue eyes, or I have hazel eyes, or whatever color that they had. So quantitative, you answer with a number. Qualitative, you answer with some type of word or verbal description. And I want to put this in a pie chart. So the way I do a pie chart is I highlight all of my values, the labels and the data, and then insert pie. And then I'm going to change it to layout 8 because that's going to immediately label each of my pie pieces and give me the percentages. So I'm going to give it a title. And what's great about pie charts is the bigger the pie piece, the more popular that response was. So 47%, almost half my class had brown eyes, and you can see that that's represented by almost half the chart. And then another good chunk of them had blue, and then a much smaller proportion had the hazel, and then other, which I think was like gray and green. I think one girl said she had purple eyes. So, and just whatever other color they had. But the pie chart's nice because you can instantly see the proportion of the pie piece that corresponds to how popular that answer was. The bigger the pie piece, the more people had that answer. The next one that we can do is a scatter plot. And a scatter plot is a way to display two types of paired quantitative data. So here we have information about the number of students per teacher and that teacher's average salary. And so we want to see, is there a relationship between how many students you have and how much you get paid? Maybe if you have fewer students, you're at a private school, so you get paid more, or maybe if you have fewer students, that's a sign that your school is less well off and you get paid less. We don't know. So we want to see, can we draw some type of conclusion by looking at this data together? So I'm going to highlight both of my columns and then insert a scatter plot without any lines connecting the dots. And I'm going to change it to chart layout 1. See, this first one's representing number of students. Then we have actually that's average salary. And maybe I'll label it students versus salary. And I always click on this data label on the right and hit the delete button on my keyboard just to make my graph a little bit bigger. So looking at this, we see there's a little bit of a downward trend. Maybe it almost looks like the more students you have, the less money you get paid, but it's not very strong. It's not a very visible trend, so I'd probably wait and collect more data before I drew some type of conclusion on students versus salary. And then the last type of graph is a line graph, and here we have information about the number of deer in a certain area of Michigan. So some biologists introduced 6 deer into an area, and then they tracked how they grew and reproduced over the next 30 years. So if I wanted to turn this into a line graph, I would highlight all of my data, and then insert scatter. This time I will get the lines, change up to layout 1. So this is number of years, the number of deer in Michigan, and then again I'm going to delete that label. And so we can see that the deer increased rapidly at first and then leveled out. We call that leveling out the carrying capacity. That shows us that the environment could support just under 180 deer with food, water, shelter, and resources. But the line is really great to emphasize that it went up and then it leveled out.